Hey, so this week and in this unit, what we're doing is thinking about atoms and elements and what makes each of them unique. So one of the first assignment you were doing on the day you weren't taking the test was a mastering chemistry assignment that related to protons, neutrons, electrons, mass number, atomic mass, and atomic number. So all of those numbers are related to these values here on the periodic table that tell us which element we have and kind of which version of that element we have. So we've got our protons and neutrons in the center. The protons determine which element it is. The neutrons determine some of the nuclear properties. The electrons, which are outside the nucleus, determine the charge of our atom. So as those different things vary, we may change if we change our protons from one element to another, if we change our neutrons from one isotope of an element to another while remaining the same element. And if we change our electrons, we would change the charge. So we might change from an atom, which is neutral, to an ion. What we're going to focus on over the next few days is the data that helps us to understand and prove what we know about atoms in terms of their composition and in terms of their mass. So we've always kind of taken for granted and been taught since a young age that atoms exist and that they're made of smaller pieces, protons, neutrons, electrons, and even that Jimmy Neutron picture of the atom. But really, those things are so small, we need evidence that can support and kind of prove these numbers and how these different symbols are different. When we're thinking of that in terms of an atom and its structure, one of the main tools we use is called a mass spectrometer. It measures the mass of atoms or molecules or ions. So the process is described here and described here, and here's a little picture. On your copy, it may not have come off super clean, so it's good to look here and kind of see what it looks like. What's happening is we put our sample in, we knock some electrons off of it so that it has a certain charge. Then we speed it up through here. So we've taken our atoms, we've taken our elements, we've sped them up, and then as we go through here, it passes through a magnetic field. Well, that magnet will attract our charged particles, but some of those particles are a little bit different. Some of them have more neutrons, making them heavier. Some of them have fewer neutrons, making them lighter. So as they go through, those lighter ones are the ones that are the easiest to change the direction of. They are the ones that have the least mass. And therefore, if we're thinking like a car trying to turn a corner, it's a lot easier for a small car or motorcycle to turn than it would be for a semi. That small mass can more easily be turned or changed. So by sending it through this magnetic field, we separate our sample into all of the different ions, and all of those different ions that, or excuse me, all of those different isotopes, can then tell me what versions of our atom or how many neutrons or what the mass is of those. So this video right here, it is a student, not one of mine, but another student that's kind of showing how this works. What they show here is they've got a ramp to roll either marbles, plastic balls, metal spheres down. And when you just roll it straight down and it doesn't have any charge, it goes straight. But some of these are metallic and are attracted to a magnet. So they've got magnets under here that cause them to take different paths because of that attraction. The ones that have a large mass and a small mass are both attracted to that magnet, but they're attracted differently. So there's the one that is not attracted to the magnet. That was plastic. Here's a heavy one that is attracted to it. It slides down the ramp, but because it's metallic, rather than going straight, it bends off. The next metallic one is lighter. So it comes down with a similar speed, but it follows a slightly different path. The magnet can attract it a little bit more or bend its path more. The lightest metallic one bends the most, following one of these paths over here. So we could separate from those the metal from the non-metal one, but we could also separate the weight of the different metals. Down here, this kind of shows that same process, but thinking of it as one step at a time. So I described it briefly. What you're going to do is kind of match up these letters to what these words do, and then think about, as it comes into here, we're breaking it into multiple different parts. As those different isotopes with different masses are measured, it makes a bar graph. If as I get more and more and more atoms that have a certain mass, that bar goes up higher. The highest bar is the one that we have the most isotopes of, and left to right tells me different things about the mass. So it says it up here, and you'll also be asked about it. Remember, the ones that bend the most are like that really small metal marble. They're very light, so it's easy to change their path. The one that bend the least are like the heavy metal marble. They do have their path bent, but not nearly as much. So depending how many different places it hits, right here it is 3, right here it is 3, up here it looks like 5 or 6. That's how many different weights, masses, or isotopes we have. As we come down here, it asks a little bit more detail about this graph. Remember, you're going to be asked questions about this, but you're also going to be able to check your answers. So learning from this and making sure that this really sinks in. So when it asks heaviest and lightest, that means the isotope with the most and least mass. Most or least abundant is the thing we have a lot of or very little of. Deflected the most means it has its path changed a lot. Deflected the least wouldn't have its path changed. And we kind of think about what these axes mean. Down here is 4 different samples, and what they're doing is showing you some graphs where we have different elements, and these are the masses of the isotopes. So just like the sample before, there was tall ones and short ones and in between. These also have talls and shorts and in between to tell us which of these isotopes are actually the most common within our sample. We may have a whole bunch with one mass and not very much of another mass, like this. We may have a whole bunch of different versions of this atom or different isotopes available that are all fairly abundant. We may have only 1 or 2, we may have 3 or 4. And as we look at the x-axis, it's telling us our masses and how many. The y-axis is how much of that do we have. So we've got some samples there where you would kind of ballpark what's the ratio of one to another. None of those estimates need to be perfect, just getting the main idea of what do I have a lot of and less of, and you're just estimating the height of your bars. And then when we're thinking about the identity, that's where we're going to the periodic table and using the information that's there. The blue number on this one, or the top number on the periodic table, is the atomic number. That is the number of protons. That doesn't correspond to mass. The red number is the average atomic mass. When I take all of my different isotopes and I do a weighted average of them, that's the value that I get. So all of these different isotopes right here, when I average how heavy they are and how abundant they are, corresponds to that number. At this point, we're just kind of practicing that. And then here, it wants you to think about what would these graphs look like? What would I have a lot of? What would I have a little bit of? And where would those be spaced maybe left to right? So how would the bars look vertically and how far apart would they be side to side? We're going to then use these skills the next day, and you can go on once you finish this and start the next day's virtual assignment. There's not a time limit on either one, and it's kind of one thing leading right into the next. So it's a 2-part assignment, kind of breaking it into 2 days. The second one has a little bit more to it and takes more time. So if you get the chance to jump into that ahead of time, you'll probably be happy you did that.